Welcome, ladies and gentlemen, to the lesson on the unit circle, where you will learn to identify and even recreate the components of the unit circle itself for both degrees and radians. In case you forgot what radians are, here's the basic definition of it. Why do we care about radians so much? Well, it's because of the fact that radians can help us solve problems, whereas degrees is more of a visual representation of angles. It doesn't actually help us solve problems per se. Next, to remind you, before we get to the unit circle, are the special angles themselves. We have 30, 60, 90 right triangle with the ratios of 1 square root of 3 and 2. And our other one is the 45, 45, 90 right triangle with the sides of 1, 1 square root of 2. Taking those special angles and tying it with the trig functions themselves, they each have a specific function value. Now, this chart primarily focused on the first quadrant, and we are going to now see what happens if we can go beyond that and tie it in with the unit circle itself. Now, the unit circle begins to take shape where we place it on the coordinate graph, xy coordinate plane, with the center being at the origin and the radius being 1 unit. So the radius itself is the distance between the center, which is the origin, to the circle itself. And tying it in with the special angles, we can start identifying different components of the degrees, the radians, and the xy coordinate points. The formula for the unit circle itself is x squared plus y squared equals 1, because remember, 1 is the radius and 1 squared is just 1. So as you can see, we can form a right triangle for every time we find a point on the graph. The question is, what are the patterns to it? So we first established the outline of the unit circle by identifying the special angles. So we have 0, 90, 180, and 270 for our quadrantal angles. And our special angles on the first quadrant is 30, 45, and 60. Obviously, we go in increasing order. Then, as we go beyond 90 degrees, we hit 120, 135, 150. Clearly, these are not the same numbers. But if you were to find the reference angle for each one of these, it would match one of these 3 original special angles. So that's why we can find a consistent pattern throughout the entire circle. Next thing is we want to establish what the radians are for each of those angles. So there is a pattern to this, and we'll go more into that later, but for the first quadrant we have 30 degrees matched with pi over 6, 45 is pi over 4, and 60 degrees is pi over 3. So notice that all of these have pi involved, because we are focused on the circle itself in the form of radians, which has to do with the radius and circumference. Pretty much just remember pi belongs to everything for radians. Next up are the coordinate values of each point. Since the radius is 1 unit, the coordinate can be boiled down to 2 specific trig functions. So this little boxed up part right here on the side is going to be very crucial to remember for what we're going to do for the rest of this video. Where if we were to find the xy coordinate point for each one of these points on the circle, remember that x can be replaced by cosine theta, that's the adjacent side of the right triangle that can be formed from each one, and sine theta is the opposite, which replaces the y value of each triangle that can be formed on the circle. So let's go ahead and expand on this so you guys can have a clear vision of what to copy down. So obviously we start with 0 and the radian itself is 0. But as we go further along, here are the degrees and radians, and here are the coordinate values. Remember that the ones in purple, the x's, are our cosine theta, and the y values are the sine theta. Notice that all of these values are positive because we're in the first quadrant. When we go to our second quadrant, rotating here, notice that all the x values, the purple values, are negative. Because remember, when we are in the second quadrant, the only trig function that's positive is sine and its reciprocal cosecant. Well, that makes sense because all our y values are positive, which is the sine. If we were to scroll down to the third quadrant, here are the values here. It corresponds with each angle. And notice that all of our values are negative because of the fact that both cosine and sine have to be negative when on down left. And the only trig function that's really positive is tangent and cotangent, but we're not really focused on that at the moment. We're mainly focusing on sine and cosine. Then the last one is here, where only cosine is positive, the x values, because we're on the right side of the graph, but because we're below the x-axis, all our y values are negative, which is our sine thetas. So, putting it all together, we can now establish what the patterns are. So notice that if we were to look at the x, y coordinate points, you can kind of see it as a pattern of where everything in the denominator is 2. Okay, all these are denominators of 2. And let's look at the cosine values, the x values. Starting at 30 degrees, you say square root of 3, square root of 2, and the square root of 1, which is just 1. So notice that it's like descending order. As for the sine itself, we're going increasing order. It's 1, square root of 2, square root of 3. So notice that it kind of switches places as you're going up or rotating around the circle. And then we get to the second quadrant. Now it goes square root of 3, square root of 2, 1. And then for the cosine, it's 1, square root of 2, square root of 3. So there is a pattern to this. So you can kind of see the 1, 2, 3, 3, 2, 1 pattern. Just have to remember which one goes with which. Best way I remember it is cosine is the x value, so you go decreasing, sine is increasing, and then vice versa for all the different parts. Another way to recognize it is associating each specific degree that share the same reference angle. So 30 degrees, 150 degrees, 210, 330 all share a 30 degree reference angle, which means that all the x values would have square root of 3 over 2, and then the y value, sine theta, would be 1/2. The only thing you have to remember is which ones are positive and negative depending on which quadrant you're in. And notice that the radians all have the denominator of 6, and the numerator varies depending on which part of the quadrant you're in. So there's one rectangle that can be formed from the 4 points. We can also form another rectangle or a square with the 45 degree reference angles. So 45, 135, 225, 315. Notice that all the radians share the denominator 4, and all of these have literally square root of 2 over 2 for both x and y. That's why 45 degrees are really nice, because the 45, 45, 90 is an isosceles triangle where 2 of the degrees are the same, so therefore our sine and cosine are the same as well. The only thing you have to remember is which one is positive or negative, again, depending on which quadrant you're in. The last one is this rectangle, where these 4 points share the same reference angle of 60 degrees, and all the radians have the denominator of 3. And these points have 1/2 in the front, in the x value, and square root of 3 over 2 in the y value, sine theta. Again, remember which one's positive or negative depending on which quadrant you're in. And there you go, ladies and gentlemen, that is the unit circle. It would probably be best for you to recreate it yourself on paper. You could try to do it on a paper plate to kind of visualize each thing.